Today we are going to see about the specific heat capacity properties. Right? So actually the specific heat capacity, which is denoted by the symbol C, right? How can you define the specific heat capacity, which is nothing but how much amount of energy is required, how much amount of energy is required to rise the temperature, of a unit mass of a system by 1 degree. Right? How much amount of energy is required to rise temperature of a unit mass of a system by 1 degree, which is nothing but specific heat. So the general formula we can give dq equal to mc dt. Right? Already you know that dq is nothing but it refers the heat transfer. Right? dt is nothing but change in temperature, and m is mass, and you are introducing the term C is specific heat capacity. Right. So again, you have to categorize into two various things in the specific heat. So which is specific heat at a constant volume, and one more thing is a specific heat at a constant pressure. Right. So actually the constant volume is denoted by the symbol C suffix P, and specific heat at a constant pressure, which is denoted by the symbol C suffix P. So again the same thing, simply we need to increase 1 degree temperature, further how much amount of energy is required in a unit mass of your system. So this is the same thing, but while increasing or the temperature, you are maintaining the property pressure or volume is assumed to be a constant. At the cases we are giving the name as specific heat at constant pressure, specific heat at constant volume. Right. So what is the formula you have to give for this one? Right. So again the same thing, dq m cp dt. Suppose if you are saying as a specific at a constant volume, likewise if you are saying as a constant pressure, this is one. You are saying as a constant volume, which is m c suffix v det t. Right. So during the 1 degree temperature, how much amount of energy is required in a system. At the cases, you have to maintain the property, whether it may be a volume or pressure. Based on that, we are giving the name as constant volume and constant pressure respectively. Okay, fine. So otherwise, you can give another formula also for this specific constant volume, depend upon the internal energy, du by dt at a constant volume. So this is another formula, which is nothing but specific heat at constant volume, which is nothing but ratio of rate of change in internal energy I already know that del u or du is nothing but it refers the internal energy, and dt is nothing but change in temperature at constant volume. Right. Likewise, we give another formula for this specific heat also. So Cp, which is equal to dH by dt at a constant pressure. Right. So we think nothing but rate of change in H, which denotes the enthalpy. Already we discussed about this the property change in enthalpy with respect to temperature at constant pressure. Okay, so these are the various kind of formulas we can use it for a specific heat at a constant pressure and constant volume based on the energy, that is internal energy and enthalpy, right? So next we will see about internal energy, right? So already we discussed about the internal energy, so I quickly recall this one, which is noted the simple U, which is nothing but stored energy within the system, right? Which is nothing but stored energy within a system. So the formula we have to given for this thing du equal to, which is nothing but Cv into dt, right? So just you can able to uh, arrange from this also. Just if you are rearranging the equation, d equal to Cv into dt, right? So else you can say suppose change in internal energy, which is denoted by the symbol del u. Simply we can say as u2 minus u1, else you can consider like this also. So you are considering some amount of mass is there. During the case of internal energy, the specific heat you have to maintain at a constant volume. So change in temperature is nothing but d2 minus d1, right? So from this equation, right, del E equal to mcv into t2 minus t1. So likewise, you can give the formula for a enthalpy also, right? Which is denoted by the symbol actually H. Already we discussed the enthalpy, the summation of your internal energy and product of the pressure and volume, which is nothing but flow energy, right? So from this also we can able to form the equation like this: dH equal to, so enthalpy means the specific heat is constant. See from here. So we can say like this also, m Cp into dt, else we can give like this, delta is equal to m Cp T2 minus T1. Okay, okay, fine. Just we will move on to next cases. Just we can say ratio of specific heat capacitance. So the ratio of specific heat capacitance, which is denoted by the symbol gamma. So gamma is nothing but ratio of the specific heat at a constant pressure and specific heat at a constant volume, which is very important parameter, right? So next you need to solve or prove that Cp minus Cv equal to R, which is one of the important relation. So we will see how can you form this relation. Already know the formula for a enthalpy, which is H equal to U plus PV. Already know the two various formulas. Please consider this formula. So next step you have to do. So what is the general gas constant equation or general characteristic equation? We can say is a P equal to RT, right? So you can replace instead of PV as RT. So next step you go for a differentiation with respect to temperature of the above equation. So you get dH by dt, which is equal to du by dt, plus if you go for the differentiation of the term, you get the constant value or around, right? And we know that already we formed the thing where you know that already we formed the formula. Cp is nothing but dH by dt. Likewise, Cv equal to du by dt, right? Just you can replace the thing. Instead of dH by, you can say as here Cp, and here is Cv plus R. So from that, Cp minus Cv equal to R. So this is the relation you can able to form by using this equation, Cp minus Cv equal to R. And you can form the some other relation also from this. Suppose if you go for solving the problem, it's really useful. Just dividing by the term Cv in above equation, right? So what will get? Cp divided by Cv minus Cv by Cv, you can get that 1, which is equal to R. Just you can rearrange the equation. Already know that Cp by Cv is nothing but gamma, right? So you can use this relation. So actually I missed the Cv here. Just dividing by the Cv on both the right hand and left hand side. Right? Gamma minus 1 equal to R divided by Cv. Right? Just you can rearrange the equation, means we get Cv equal to R divided by gamma minus 1. So this is one of the important relation which helps while solving the problem. Please make a note. Likewise, if you go for that, dividing by the equation 2 by the term Cp, let's see what will happen. Cp divided by Cp minus Cv divided by Cp, which is equal to R divided by Cp, right? So Cp get cancelled, so you get 1 Cv by Cp or divided by Cp. You know that gamma equal to actually Cp by Cv, so we can write as 1 minus 1 by gamma or divided by Cp. So if you're taking the LCM, get like this, gamma minus 1 divided by gamma, which is equal to R divided by Cp. So from this you can form the Cp is nothing but gamma into R divided by gamma minus 1. So this is another relation. You can able to find out the value of Cp.